In this video, we're going to talk about transfer scenario order. So this is the very first one in the model efficiency results of way of cutting down the time of running your models. So let's talk about a scenario. Suppose you have 50,000 policies and you're running 10,000 scenarios on those 50,000 policies. And the reason why we want to do this is we want to find a tail metric, such as our CTE 70. And if we have our CTE 70, that means we just need to find the 3,000 worst scenarios, and we're going to take an average of those, and that's our desired output. That's what we want to know. And that's what we want to do for setting our sensitivity testing or reserves, etc. And we're going to run these 10,000 scenarios, and you get an output like this. And one of the reasons why you need to run all 10,000 scenarios is so you can know which 3,000 are the worst of these 10,000, so you could calculate your CTE 70. Now, this might take a really long time to do, running your 50,000 policies on 10,000 scenarios. But the idea is, with transfer scenario order, hey, if we could find a way to quickly identify which are the very worst of the 10,000 scenarios, then we could have cut down our model time and just run 50,000 policies on those 3,000 scenarios. Now, that would be ideal, but we got to be really careful. In the transfer scenario order, it is a little bit careful. It has a little bit of a buffer there because it has two runs that you're going to do instead. And the first run you're going to do is you're going to do a subset of these 5,000 scenarios. So let's say now our first run we do a random sample of like 5% of our policies, so 2,500 policies, and we're going to run that on our 10,000 scenarios. And then once we run these 2,500 policies on all of the scenarios, it might get us something that looks really similar to what it really would be. And so we're going to select, just to be safe for this very first run, instead of selecting the 3,000 worst, we're going to actually add one more 1,000 of the scenario. So we're going to do the 4,000 worst. And then that way we can, in our second run, identify which are the 3,000 worst later. So this is our first run right here. And then in our second run, we're going to do all 50,000 policies based on these 4,000 scenarios right there, and we're going to pick the 3,000 worst. You see how we got to the same result using two runs, but these two runs combined on the runtime is significantly less than this one time. Now you'll see in the summary right here, it actually says that the runtime reduction is low. I kind of disagree. I thought it looked like it was pretty good, but we're just going to stick with that. It does reduce your runtime. Now, the disadvantages of this is that it does, it's only good for looking at your tail metrics, and so it's not very good at looking at like your mean, because what we just did is we just picked the worst. Another thing that might be, another disadvantage they mentioned in the reading is, what if using this subset of the 2,500 policies and you selected the 4,000 worst? Well, let's say that these 3,000 worst, if you were using all of your data, let's say some of those were actually not included in the 4,000 worst, and so you wouldn't truly pick your CTE 70. You actually picked something that was a little bit skewed to being less conservative. And so that way, that being said, for using this transfer scenario order for stat reserve calculation, it's not conservative, and so it's a little less desired. It might be pretty good though to use for sensitivity testing. Maybe it's just, maybe you're not too concerned about it, and it's like, you know what, like maybe we lose a couple of conservatism, like a little bit of it, and we're willing to deal with that. And you could test it out and see if it's worth it, and there you go. So this is the first one.